We got the pleasure last year of being first, and we didn't know what we were getting into, so Dante said, we'll try it again this year. Our team, FMTC, which is Fort Myers Technical College, and they're the techies, I'm just the talker. One of the things that impressed me about this is that, interestingly, whenever there's a fire, there's a natural disaster, you always see everybody running away from the disaster. But then there are these people called first responders that are always going towards it. And the latest one was, I just saw something on the TV and they were talking about the Boston terrorist incident, which is on the lower right. And the interesting thing was, the bomb had just gone off and those guys were already running towards the bomb, which most of us are not going to do. And Heather told me the other day, which was sort of an interesting statistic, that most firefighters retire by the age of 52. But the tragic part of it is, 10 years later, most of them have passed away, and they're not even quite sure why. They have a lot of health problems because of the toxic environment that they work in, and that's not at the firehouse. I think what we'll do now is we'll pass it off to Will, and he can explain a lot more about LiveSense.
Hello again, everyone.
Yeah, Will. Welcome.
So, what I showed you before was what we've done today. But now what I'm going to talk about is what we are planning to do. LiveSense is the name of basically our data collection platform that we are designing. As you can see in the slide, we've given an image of an interconnected web, which is what we plan with LiveSense. All these different sensors, all these devices that collect data connected through just the internet or wireless, local wireless connections in the case of a fire, and they just build a network that allows you to see how things are changing live, as the name LiveSense. Now I'd like to talk to you about how we do this.
Okay.
As you can see, we go from the sensors, the top file, through PHP, the database, and then the CSV file goes into Watson SQL. Okay. Watson takes that data and analyzes it and makes smart predictions about what we're doing and what we can find out about, what does this temperature mean? Does that mean that, there's this temperature, there's this gas, and there's X, Y, Z conditions? Does that mean that this is what is causing X, Y, and Z? All this could be figured out through Watson and our data. So the sensors we've used in our demonstration, very, very few. Only temperature and a gas sensor. The temperature was all we had time to show you earlier. But you can have a wide range of sensors that are compatible with our platform. Anything from just the basic gas and temperature to something amazing. MIT had recently made an article, basically a study, all about how they made an X-ray technology using Wi-Fi points. What it allowed them to do was, through their one router and someone in another room, just with a cell phone in their pocket, they could see whether they were moving. They could see, okay, this signal, this wave, bounced off XYZ solid object. It allows them to make somewhat of a map, just somewhat of a 3D map of the space. That and so much more could be implemented through the sensors. And now I'd like to hand it over to my friend MC to tell you about some of his code.
Thank you, Will. Hello everyone, my name is MC Luigi, and my task was to create a database that everything that I would receive from Will, and I would store it in MySQL database. The next thing is that every sensor, every node that receive, like let's say we have a sensor that receives temperature, and on this room, the temperature, I will receive it and store it in real time, like, and times 10. So that's not only you will see it in the database, but you will store it on a way that even though you go, like, let's say 10 years later, you will still see that event that happened on that time that you received the temperature. Or any sensor that I received from Will. And he will export it to a web server that is PHP code that Dean will pretty much explain more about it, because that's his code.
Thanks, MC. Good morning. My name is Dean. I did a lot of that work for the PHP code. What the PHP does, for those who aren't as tech savvy, is more of like the middleman between the database and the actual sensors. So the sensor says, hey, it's hot over here. The PHP code says, all right, it's this much data. It's this temperature, or it's this much, and it'll be stored into the database. What we plan to do with this, what the PHP also does is that it will transfer all this data into a cloud system provided by IBM Analytics. As the main brunt of it, I want to pass it over to Dr. Monty Toffee, and he's going to explain the Watson Analytics and how it's used to further save lives.
Thanks, Dean. As Dean and actually MC implied, some of that data that is time-stamped into the database is going to have a lot of uses. It's not just real-time data that firefighters can use, but it actually provides forensic data that can be searched, data can be crunched, and predictive analysis comes from that via IBM Analytics. The other advantage is a permanent legal record of a fire is made. A lot of times after the fact, people don't understand that there are legal implications to fires that sometimes come up in court situations. So IBM Analytics allows us to do that. Regarding the IBM Watson Analytics, some of you remember that first slide? It pointed to something called Big Insight. And we understand the need to gather data locally for local fire departments. But we also understand the need to gather data on a macroscopic level. There would be real value from getting the data from fire departments really all over the world and crunching that data. But what's the limitation? Traditional methods fall far short of that. IBM's Big Insight is a means of handling what's known as big data. Now, most of us have heard that term. It's the real sexy term everyone knows about now. But what does big data mean? Well, it's data that changes quickly. It's data that comes from a variety of sources and a few other things. We won't go into all of it, but you can see the problems if you're trying to mix an Excel spreadsheet with a MySQL database. So various tools interface with Watson Analytics and Big Insight to be able to make that seamless. There's tools like Hadoop and MapReduce, which is software that we had planned as our final solution to incorporate, but again, ran out of time. So we're excited about what we were able to accomplish on a paradigm level. We did also want to kind of step outside the box. We heard that term earlier yesterday, and propose a hardware implementation of our software solution. I'm involved with some instructors over at Georgia Tech, and I'm aware of some research that's being done at Carnegie Mellon Institute regarding something I'm a big fan of. I love snakes. I've always liked snakes. When I was in intermediate school, I stuck my hand in a tunnel in a pond to try to catch a snake, got bit and went to the ER. So well, that's another story. But
It's like a commercial, but it's not poisonous.
exactly, exactly. So this is more of a case study of what could be implemented. So snake bots are something everyone's heard of. They've been used in ER emergency response situations for a long time. Snake bots were first developed through a common effort between Georgia Tech, Carnegie Mellon, and Zoo Atlanta, where they studied the Sidewinder rattler. Has anyone seen a Sidewinder rattler? You know how it moves. It goes in and out, and it's capable of going up inclines. So they studied the movement of a Sidewinder rattler and came up with locomotive data that helps us understand that and use it in a robotic situation. And by the way, the term for that is biomimicry. Go figure. So it mimics the motion of the snake. Now, our intent is not to reinvent the wheel and come up with some snake bot. That's been done. However, what has not been done is a snake bot delivery system. What we're proposing, and this will take a few years of research, but we're proposing, and we will begin this ourselves as a team, is to create the same technology in the snake bot, but as an outer shell. So if you can picture a hollow snake bot, which contains different sensor delivery mechanisms. So we envision, as you can see from the photos up here, we envision dropping off, much like a snake lays eggs, dropping off sensors in a fire scenario, creating an ad hoc wireless network of sorts that can communicate. As you guys know, one of the biggest obstacles to Wi-Fi networks is blockages, solid structures blocking them. So if we can create that little chain from the external to the fire and do it with an inanimate object, we can help firefighters, we feel, improve their safety and other factors. We also envision, in addition to the hollow snake, the snake bot, we envision a way to deploy smaller snakes that have sensors attached for various purposes, possibly even extraction mechanisms, but they would also have sensors where the large snake could not go. They would come through the mouth of the snake. And people are looking at me now like this is a joke. But we also envision drones being able to come from the snake itself in scenarios where that might be appropriate. So
We're done on time.
that's about it. I guess we don't have time for Q&A. Thanks a lot.
Thank you. That was great.